everybody? Johnny Bannon here with Trepa Technologies, and in this video, we're going to be going over our standard ACL lab. So if you're watching these videos in order, you just got done with us going over ACLs, standard, extended, named. We got everything, right? We went over everything about ACLs. And in this video, now we're going to be configuring standard ACLs. So if you're following along, if you purchased our course, thank you. You already have access to our lab and all the material. But if you're watching this on YouTube, click in the description below to go to this GitLab link, and this will give you all the instructions for all of our CCNA labs. It's an open resource that we give to all of our students. Now, that being said, let's go ahead and get started. So I'm gonna make sure that my face isn't taking up the whole screen here, just a little bit of the screen, that's all we need. And now, let's go ahead and take a look at our GitLab repo. We're in section 8, and we're going over ACLs. So the ACLs we're gonna configure right now are standard ACLs, and I'm going to drag this lab, this document, this markdown document over to the other monitor you guys can't see, and we're going to go through it. So the objective, create standard ACLs and now apply them to interfaces and V2Y lines. So we're going to go ahead and do that. And the first thing we got to think about when setting standard ACLs is placement. Standard ACLs just filter based off the source IP address. Since it filters just off the source, you can imagine the kind of complications we can get. If we're trying to deny traffic from, let's say, this subnet to this subnet, and only thing we're filtering on is just the IP address, so we can't specify a port or a protocol, and we just want to deny web traffic, like port 443 or 80 from this VLAN subnet, right, to this subnet, and we're using a standard ACL, which just filters off source IP, and we apply it here, well, guess what? We just denied that entire subnet access anywhere. We just denied them fully. So with standard ACLs, you're going to want to make sure that we place the standard ACL as close to the destination as possible. So now let me set this mic down and go through this lab. Let me clear off some space. So if we go up here, we're going to see the lab setup, 2 Cisco routers with console access. We're using EVE-NG to simulate or emulate these Cisco devices. And what we have here is our security standards. So we just got done talking to the SOC, and they say, hey, we need the NOC engineers to do this. You're a junior network administrator, so the senior network administrator is going to configure the next generation firewall, and you're tasked with these standard ACLs. You don't want to mess it up because you just got your CCNA, and now you're in the NOC finally. Let's go ahead and do it. So step 1, users in VLAN 20 should not be able to ping both servers. Again, since we're talking standard ACLs, we won't be able to just deny ICMP traffic. We're going to have to deny the entire subnet that's a part of VLAN 10. Users in VLAN 20 should not be able to SSH to R1. So again, we cannot deny just based off SSH. So what we're probably going to do here is on R1, filter out VLAN 20 users on the VTY lines. So I'm going to show you how to do that. So instead of applying it inbound or outbound to an interface, we can actually apply it to just a VTY lines. And then we have the file server should not be able to reach the engineering VLAN. So let me just scroll down a little bit. As you can see here, our file server is this host IP or this IP address. We do not want them to reach the engineering VLAN, so we want to make sure that we block it. So again, if we look at our network diagram here, and we know we got to place them as close to destination as possible, if we're denying VLAN 10 users to our server subnet, we want to apply it as close to them as possible, which would be right here on R1, outbound. And then we want to deny SSH to R1 from VLAN 20 users. What we can do here is instead of applying it to an actual interface inbound or outbound, we actually will apply it to our VTY lines. So that'll stop any remote connections coming in from VLAN 20, any remote connection. So telnet, SSH. And then our file server, we don't want them to reach this entire subnet here, but just our file server. So something we can do with standard ACLs is just pick out a single IP address to be filtered, a host address. So what we're going to do here to apply it as close to the source as possible, the source being protecting VLAN 20, is going to be outbound on R2. So with that being said, let's go ahead and now get started into the actual CLI, getting our hands on. So what I'm going to do now is drag over this GitLab repo to my other monitor, and I'm going to follow this lab. First thing we're going to do is open up CLI connections to all of our devices. So now step 1 is we want to apply an ACL outbound on ETH00 to protect our server subnet from VLAN 10 IP addresses. Maybe we think they're all hackers or threat actors, okay? Behind the scenes, because a lot of times when I was learning CCNA, the instructors were so focused on the technology, they forgot to go over how the rest of the network is configured. So let me just briefly go over that with you. I'm going to drag my CLI kind of out of the screen. Okay, so what we have here is I configured access VLANs here, access VLAN 10 and 20. 10 here, 20 here. Right here on this switch is a trunk port. So you have to configure a trunk. Then right here I have 2 sub interfaces created for both my VLANs as the default gateways. And then of course I have an IP address here between R2 and R1. And I just configured static routing between them. You can do a dynamic though. You can do OSPF, ERGRP, RIP. It doesn't matter. We just need to have routing between these two. I did it static. And then we just mirror the configuration. So I did end up putting a sub interface here under 00. Don't need to since this is the only network we have in this LAN, but I just did it just to apply the ACL outbound on the sub interface. And then of course we have our VLANs here and the trunks created here. Okay, so that's what we have configured in the background. That's how we set up this network. We have full reach ability as of right now. So step 1 is we want to deny ping access. Maybe we're stopping, ICMP flood attacks from VLAN 10 to our server VLAN. So the first thing I'm going to do is I'm going to go into PC5 here. And I'm just going to do a constant ping over to the server subnet. So we can do that by typing in ping 10.10.9.1-T. And now we have a constant ping. So we want to create an ACL to deny this. Now before I do this, I swear we're going to do the CLI one day. I'm going to go into R2 here and I'm going to do a packet capture on ETH01. And I'm going to leave that packet capture going. So we're going to bring up Wireshark and we're going to see the ICMP messages coming back and forth. And when we apply our ACL, we're going to dive into this ICMP request and reply and see how it differs. So if we just take a look at this one right here, we can see this is a request and it's getting responses back. You see the source being our VLAN 10, destination being VLAN 900 of that server subnet, okay? So now let's go ahead and actually do the ACL configuration, what we're here for, right? So since we want to place the ACL as close to the source, as close to the destination as possible, we're going to create the ACL on R1 and we're going to apply outbound on ETH00.900 because that's the sub interface that's doing the routing for that server subnet. So let me bring this into view here, make sure it looks good on the screen. Okay, so first, of course, we got to log into R1. And then we're going to create our standard ACL. So it's going to be IP access list 10. And then we're going to... Actually, that's going to make a named one. The command is access list 10. And then we have 2 options here. Then permit or deny. And then we have a remark here. That's just a comment about it. We're not going to do that. That's just administrative stuff. So we could put this is to deny VLAN 10 to VLAN 900. That's just a remark. So when we do our show commands, we'll be able to see that. And then it's like a comment if you've done any coding or programming before. Access list 10. We're going to deny the 10.10.10.0 subnet. And we're going to do a wildcard here. So it's /24 wildcard. And we're going to hit log. And then we don't want that implicit deny at the end. So we're going to do permit any and then log. Okay. And now since we want to apply as close to the source as possible, if we type in do show IP interface brief, we see here that this sub interface is what is the default gateway for our server VLAN. So now let's go ahead and before we get started, let's actually do this ping instead because I foresee issues. Let's actually ping the server itself. Okay. Let's see what the IP address is of that server. Show IP. Oh, it's .10. So we're going to do a .10, excuse me. Okay, now let's go back into R1 and now apply that ACL we just made. So before we apply it, if we do show run section access, we can see this access list. So it's to deny VLAN 10 to VLAN 900. We're denying VLAN 10 traffic, then permitting anything else. So from VLAN 20, we should still be able to reach the server subnet. Then if we type in do show access list, we can see here that we have our two ACEs, or access control entries, this deny statement and this permit, and we're logging it. So we'll be able to see matches across here, okay? Now, let's actually get into our interface, 0/0.900, and this is going to be the command. It's going to be IP access group, and then we're going to define if we have a named or standard or extended, and then we have to choose the direction. We're going to click outbound. Now that we have applied this ACL, let's go see our pings. And it's pretty cool because even here we're getting like communication administrative prohibited instead of just no connectivity. And if we come back to our Wireshark capture, now we're getting as replies destination unreachable. If you guys can see that, let's go ahead and stop this. So before, we were getting, if we just scroll up, these requests and replies saying, hey, everything's good to go. And then once we applied that ACL, you can see it happen right here. No response seen. And then this router here, 24.2.2.1, which would be, if we look at our diagram, R1 is actually telling us, hey, the destination is unreachable. Because that is a device that's actually doing the filtering. So we're actually doing filtering at R1, and it's replying to us saying destination unreachable. We have a type 3 code 13 communication administratively filtered. Pretty cool. I think it's pretty cool. And now let's go ahead and check SSH access. So I think that's step 2. Now we're going to filter SSH access. We're going to cut off this ping. So what we're going to do here, guys, is this PC doesn't have SSH capabilities. So we won't be able to test if VLAN 20 PC can SSH into R1. What we can do is from R2, here's how we can test to see if that SSH request coming from VLAN 20 will work. So what I'm going to do here before we get started is I'm going to kill this old Wireshark capture, quit without saving. I'm going to start another one right here because I want to show you guys how SSH looks on the wire. Okay. So we're doing packet captures on that interface. Looks good. From R2, what we can do here is type in SSHL, give it a username, 24.2.2.1, and then we can pick, actually it should be right here. Okay, so what we're going to do here is we can't pick a source, actually, like you can with Telnet. So we're going to switch this up, actually. Let's go ahead and see if we can Telnet here. Connection refused. So let's go into R1 and make sure that our line cards are good to go. So we'll go into line VTY 0 type 4, transport, input all. So we're going to change it up here. Now we're going to test Telnet, because with Telnet you can actually source where you're coming from. So I don't think you can with SSH. Yeah, number, password, it's okay. What we can do with Telnet though is when you Telnet into a device, you can pick where it's coming from. So we can say source interface is going to be ETH00 TAC20, which means now when we Telnet, if we go back and look at that Wireshark capture, we can see that we're starting that Telnet session from VLAN 20. Now, if we exit out of here and we just Telnet without picking that source, it's just coming straight from the router's interface that's facing it. So we're going to make sure that we're actually filtering based off VLAN 20. So how we're going to do that is, again, we're going to go back into R1. We're going to create an access list. So access list 20, remark, deny VLAN 20 telnet. And then we're going to do our deny statement. So deny 10.10.20.0/24. And we're going to log it. And then we're going to do a permit as well. So we're going to do permit any log. And now let's go back to R2. And let's get out of here from this telnet session. And what we're first going to do is make sure that we can telnet across, okay? So now let's go back into here, get into our VTY lines, all of our VTY lines, and to apply an access list to a VTY line, it's going to be access class 20 inbound, okay? That's how we apply it to a VTY line, access class. We're going to go back to R2, see if we can telnet in, and we can. Now, why is that? Because if we actually look at the Wireshark capture, it's coming from this source address, 24.2.2.0. On R1, if we do show access list, access-list, you can see here that it is only denying 10.10.20 IP addresses. You can see this permit any, there's a match. Pretty cool, right? Now, if we go back to R2, let's exit. Let's try to telnet. And we'll pick the source interface as eth00.10. So we'll see if VLAN 10 users can access it. And look at that. They can. Now, for our actual test, let's see if VLAN 20 users can access it. And it says no, connection refused. So if we come down here and look where our telnet started, so you can see there's the telnet request coming from VLAN 20, 10.10.20, and look at this deny. It's saying, hey, nope, you cannot telnet in. So pretty cool. We can actually see this happening on the wire itself. Now, for the last thing we're going to do is we're going to make sure that the file server cannot reach VLAN 10. So how we do that, and we're just going to apply the ACL, and we're not going to test it because I feel like we've done enough tests right now. Since we're stopping the file server from reaching VLAN 10 as close to the destination as possible, we're going to go into R2. We're going to type in access list 10, remark, deny file server to VLAN 10, then access list 10. And what we can actually do here is just deny a host. And we can just put 10.10.9.10. And then we can do our permit any statement. Permit any. I forgot to put the log keyword. That's okay. And real quick, actually, if we just show access list again, you see there's that match here, denying. Pretty cool. All right. So now, here, instead of denying the entire server subnet, what we did here was just deny a single host. So pretty cool. And then to apply it again, we're just going to go to interface.10 because that's where our default gateway is for our VLAN 10 users. And we're going to type in IP access group 10 outbound. And now that completes our standard ACL lab. So if you guys have any questions, please feel free to reach out to our team. If you want some in-person or live virtual training delivered by Trepa Technologies, please feel free to reach out. We'd love to come to your unit organization and train you. We're also a vendor on the Army Ignited system, meaning that if you're an active duty reserve or National Guard soldier, you get $4,000 a year for credentialing assistance. And you can use that to come to our self-paced or live virtual training, and you get a voucher for free, all from the Army. Isn't that great? So thank you for viewing, and do not forget to like and subscribe.